Hey, this is a review of the energy conservation packet that we did in class. Hey, so first part was we drop our egg device. That was our safety device we made last week. It has a mass of 0.5 kilograms. We drop it off of our friend's house. We really want to test this thing. So it's 50 meters high. That's pretty high. It's about 160 feet. So we want to check or calculate the gravitational potential energy, the kinetic energy, and total energy, and also the dissipated energy, and velocity when we first drop it. We have a dissipated energy of 0, okay, halfway to the ground. We're given the amount of dissipated energy, and right before it hits the ground. Some special cases here. When we first drop it, our velocity is going to be equal to 0. Just as my hand opens, then it starts moving, but at that instant I open my hands, the velocity is 0. And then right before it hits the ground, we have the special case where our height is going to be equal to 0. Let's go ahead and start filling this in. Okay, so something I see here, my total energy is my potential energy plus my kinetic energy plus my dissipated energy. Okay. My potential energy is going to be mass times gravity times height. We'll figure that out in just a moment. My kinetic energy I can determine from 1/2 mass times velocity squared, but in this case I already know my velocity is equal to 0, so my kinetic energy is going to be equal to 0. And my dissipated energy just given to me is 0 as well. Hey, let's come back and figure out our potential energy. Our mass is 0.5 kilograms, gravity 10 meters per second squared, and the height we're dropping it from 50 meters. 0.5 times 10 times 50, I get 250, and we're measuring energy, so it's measured in joules. So I have 250 plus 0 plus 0. My total energy is 250 joules. That's going to be important because that's going to stay the same throughout our exercise here. So my total energy, I'll go ahead and put this in the form of a bar chart. Some of you may have taken a look at the bar chart when you were doing the skateboard or skate park simulation. Hey, let's take a look at what types of energies are present there. Kinetic energy, we have nothing, so I'll just put an X to indicate that I haven't forgot about that. Dissipated, I'll do the same thing, put an X to indicate I haven't forgot about it. Hey, so all the energy that's here, this level indicates 250 joules, okay, is gravitational potential energy. Okay. And then in our energy pie here, this was done with the energy skate park. Hey, this represents our total energy, and the total energy, the only type of energy present, is our potential energy. Then I know my pie chart is all potential energy, 250 slices of potential energy. Okay, let's go ahead and we'll move on down to the next problem. Hey, so in this case I'm halfway to the ground, and I'm given the dissipated energy. Halfway to the ground tells me that my height is now 25 meters. Energy is a conserved quantity, so I know my total energy remains the same, 250 joules. My potential energy, mass times gravity times height. My kinetic energy, hey, not sure what that is. Dissipated, it's given to me right here, 2.5 joules. Let's figure out what we know. Hey, so mass, 0.5 kilograms, gravity 10 meters per second squared, and my height now is 25 meters, so my potential energy is 125 joules. My total energy, which is going to be the sum of dissipated plus kinetic plus potential, has to equal 250 joules. So another way of saying that is my kinetic energy is going to be equal to my total energy, and I'll subtract the things that I know. I know that my potential energy is 125 joules. My dissipated energy is 2.5 joules, so 250 joules minus 125 joules minus 2.5 joules is going to be equal to 122.5 joules. Let's go and fill out our bar chart. Again, our total height there is going to be 250 joules. My potential energy is just right at half of that, so I'll kind of fill in about half of that bar. My dissipated is a real small sliver down here. Okay, my kinetic energy just under half, a little bit less than the potential energy. This gives a representation of the type of energy. This is pretty qualitative. I'm not worried about exactly how high these are, but it gives an idea of what's available. Again, my total pie chart area tells me the total energy, so I'll divide this up into slices. So I'll try to divide this about in half. I know that half of this is potential energy. The other half, okay, there's a small sliver or a couple of slices of dissipated energy pie here. That's my dissipated energy, but most of this half is kinetic energy. Okay, I'm also being asked, hey, what's the velocity here? So I'll use the 5-step process in solving that. Scroll that in here. Step 1 is make a picture. I'm going to go ahead and do that. Big fall over here. Dropping that package about halfway down. I know it's 50 meters to the top of this building, and this is at 25 meters. Okay, so let's go ahead and what am I trying to find? I'm trying to find the velocity as it hits the ground, so velocity at the halfway point, maybe we can call it that. Whoops, not as it hits the ground, at the halfway point, at 25 meters, right? 3, what am I given? I'm given a couple of things. The mass is 0.5 kilograms. I know that gravity is 10 meters per second squared. I know that the height is 25 meters. What else do I know? Oh, hey, I know that the kinetic energy is equal to 122.5 joules. Next, I'm looking for relationships. Hey, I want to find a relationship that tells me my velocity at the halfway point, given some of the stuff that I know. First semester, we could use several different things. I could look at my unbalanced forces, figure out how far it's fallen, figure out how much time, look at velocity as acceleration times time. Pretty complicated process. Or what's handy is I do know that there's this relationship. Kinetic energy is equal to 1/2 mass times velocity squared. Hey, I know kinetic energy, I know mass, and I'm looking for velocity. That'll serve us pretty well. Okay, but if I did it a different route, figured out unbalanced forces, acceleration time, I would get the same answer. But this looks a little quicker. Hey, let me go ahead and manipulate this a bit. So I have my kinetic energy is equal to 1/2 times mass times velocity squared. Sorry about my penmanship. I'll multiply each side by 2 to clear that fraction. I'll divide each side by mass because I'm trying to get velocity all by itself. So I get, well, come on up over here, 2 times my kinetic energy divided by mass is equal to velocity squared, but I'm interested in velocity, so I'm going to take the square root of each side, and I get 2 times the kinetic energy divided by mass. The square root of that is going to equal velocity. Let's go ahead and put numbers in here. So 2 times 122.5 joules divided by 0.5 kilograms. Take the square root of that. Let's see what that equals. I'm going to bring up my calculator here. Okay, so clear that. So 2 times 122.5 equals, divide that by 0.5. Oops, clear that. 0.5. Clear that. Oh, let me start again. Sorry about that. Clear. 2 times 122.5. Divide that by 0.5. Okay. And I'm going to take the square root of that. Okay. I get 22.9. Hey, so I get, okay, hope you saw that there. Okay, 22.1, 22 meters per second. Remember, a square root can be a plus or minus because it's falling down. I'll call it minus 22 meters per second. If I was only looking for speed, or if I called down positive, I could call it 22 meters per second. Let's move on to our last part. Okay. Right before it hits the ground, I have 6.2 joules of dissipated energy. Hey, if it's right before it hits the ground, I know that height is going to be equal to 0. Hey, so my gravitational potential energy is also going to be equal to 0. Okay. I know my total energy is 250 joules. I'm not given a velocity, but I do know that, just like last time, my kinetic energy is going to be equal to my total energy minus the energy that I know about, my potential energy and my dissipated energy. This one's going to be pretty straightforward, 250 joules. The only energy I have to worry about is the dissipated energy, 6.2 joules, so I get 243.8 joules. Let's go ahead and fill in our charts. Okay. Potential energy, nothing here. Dissipated, there's a little bit of dissipated. Okay. And a lot of kinetic. Most of our energy is, in fact, kinetic energy. We can represent that here, too. Some dissipated over here, but a lot of kinetic energy. Okay. And the last thing we want to do is figure out that velocity. We'll use that 5-step process again. Okay. Hey, I'm going to use an abbreviated format. We've done a lot of this already, so I'm saying, hey, my picture looks like this now, is that our bag is just about, it's just impacting the ground. You can see it's going faster. Makes sense. Person dropping it there. Okay. Hey, so I'm just going to cut a bit to the chase on this one. I already know that, hey, I have a relationship that my velocity is equal to 2 times the kinetic energy divided by mass. Okay. In this case, hey, so 2 times my kinetic energy, 243.8 joules, divided by 0.5 kilograms, and I'll take the square root of all that. Bring up my calculator again, we'll see what we get here. Hope you can see that all right, so I'll clear this. So I have 2 times 243.8 divided by 0.5. Well, let's see. Mess that up again. Clear. Okay. 2 times 243.8 equals, maybe I divided by 0.5. This looks a little better. Equals, okay, 975. Take the square root of that. About 31 meters per second. So that's going to be 31, if we want to be fancy, we could say 31.2 meters per second. Again, this is going down. Okay, so I'm going to call that minus. I'm going to take the negative root there. Okay. Hey, a couple of helpful hints on the next section. All right, scroll down here. Okay. Hey, you launch your water rocket. We're given a mass and determine that 2 meters off the ground. When all the water is gone, it's going at a speed of 30 meters per second. Okay. We're going to go through and we'll take a look at this first one. Hey, so calculate our potential energy, kinetic energy, total energy, height and velocity when, hey, it's at 2 meters. We'll take a look at that one. Okay, so at that point, our dissipated energy is going to be 0, but also notice that we do have a velocity, is 30 meters per second, and we do have a height of 2 meters. So let's go ahead and take a look at that. Let's get you started so you know the total energy. All right. Hey, so our potential energy is mass times gravity times height. Our mass, 0.55 kilograms. Gravity is 10 meters per second squared, and our height is 2 meters. You can go ahead and figure that out. 0.55 times 10 times 2. Kinetic energy, we know, is 1/2 mass times velocity squared. 1/2, our mass is given to us, 0.55 kilograms. Our velocity, 30 meters per second. And remember, Aunt Sally, remember PEMDAS, order of operation, you want to do that squared operation first. Okay, I'll let you determine that. Dissipated energy is 0, but just make sure you're off on the right foot. Let's see. Your total energy, when you do this correctly, you'll get is equal to our potential plus our kinetic plus our dissipated is going to be 258.5 joules. Okay, use that as your total energy on each of the steps because remember, energy is conserved. It can be transformed from one type to another, maybe moved from another object to another. We're not going to worry about moving it to another object, so just transformed. But our potential, kinetic, and dissipated energies add up to the same value each time. Good luck with that.